Hi everyone, it's Math with AUB. Let's commence the work on the project of IBA direct test final touches. I think it's frame 18 or 19 of 23. 19 of 23. Let me change marker. 19 of 23. So without wasting time, our question number 1 reads as I have told you several times average speed, average rate, whenever work is same, always switch over to harmonic mean formula. Harmonic mean formula is the best way to get good guess of the average. Let's see and find out. Our question number 1, I have one-legged glasses. In the afternoon, Judy read 100 pages at the rate of 60 pages per hour. In the afternoon, Judy read 100 pages at the rate of 60 pages per hour. In the evening, when she was tired, she read another 100 pages at the rate of 40 pages per hour. In pages per hour, what was her average rate of reading for the day? Average rate of reading for the day. Average rate of reading for the day. In both cases, in the afternoon, she read 100 pages. In the evening, she read 100 pages. But the speed varies. Rate of reading varies. 60 pages per hour in the afternoon, and in the evening 40 pages per hour. Simple is that switch over to harmonic mean formula that reads as whether to take rate 2 times the rate 1 times rate 2 upon sum of the rates R1 plus R2. The simple technique to find average of the speeds or average of the reading speed or average of the work speed, that's the formula. We have rate 60 pages per hour. First one is 60, the other one is 40. 60, other one is 40. Other one is 40 upon sum of the rates 60 and 40. It's 2 times 60 times 40 over 100. Cancelled out, another 0 cancelled out. I have 6, 2 6 the 12, 12 for the 48 pages per hour. 48 pages per hour. 48 pages per hour is the reading rate for Judy. Many people do not concur with this idea and they follow the traditional path, orthodox path. It's also same. It leads you to same result. It leads you to same results. Let's see how. Let me raise this. Whenever you have given average speed, it is the problem that has been sugar coated. Instead of distance, he has given us 100 pages. He read 100 pages, 100 pages. Normally, there is distance from going home to work and work to home. Same distance. Here, 100 pages in the afternoon, 100 pages in the evening. They are the same. Work is same. The rate is different. 60 pages per hour and 40 pages per hour. So, harmonic mean is the best option to be utilized. Otherwise, you take the traditional path, which is as follows. Find the rate in the first case, 100 pages at the speed of time for event 1, 100 pages at the speed of 60 pages per hour, cancelled out. So first time is applying table of 2, 5 over 3 hours. What about second time? Second time same 100 pages but at different rate, 40. 100 pages divided by 40. Oh, cancel. Apply table of 2. T2 is our 5 over 2. So total time T1 plus T2. I have 5 over 3 plus 5 over 2. Taking LCM 6. 2 5 the 10, 5 3 the 15. 25 over 16. 25 over 16. That's my total time. Total time. And total work that we have to, she has to complete 100 pages in the afternoon and 100 pages in the evening. So total work is 200 divided by 25 over 6. it will become 200 times 6 over 25. 200 times 6 over 25. Same situation. Table of 25. How many times? 5540. 58. I have 8 times 6. 8 times 6, that is 48 pages per hour. 48 pages per hour. That is the same rate that we have calculated in the direct formula, that is 2 times rate 1 rate 2 upon sum of the rates. Sum of the rates, or you can say sum of the average speed of the reading. Average speed of the reading, or average rate of reading, or average rate of reading. Harmonic mean is the best mean to be utilized to find the average of anything. When we have given 100 pages, work done is same, work is same, 100 pages, 100 pages. In the evening, in the morning, in the afternoon, in the evening, work is same. It's best strategy to follow harmonic mean. Harmonic mean. Okay. So in that case, our rate is 48 pages per hour. Moving towards question number 2. It is based on consecutive integers. If the sum of 5 consecutive integers is s, if the sum of 5 consecutive integers is s, what is the largest of those integers in terms of s? In terms of s, 5 consecutive integers, 5 consecutive integers. Consecutive integers differ by 1. Simply, you can write x plus 1, x plus 2, x plus 3, x plus 4, x plus 5. Their sum is equal to s. I write s like 5. That's why I am writing s in that fashion. Sum of the integers is 5. Sum them x, 5 times x. 1, 2, 3, 6, 10, 15. 15 is equal to s. Let me solve for x. 5x is equal to s minus 15, or x is equal to s minus 15 over 5. That's x. We are asked to write largest integer. Largest integer, we have taken x is positive, that is smallest, greater than x plus 1, x plus 2 by 1, by 1, by 1, it is longest, it is largest of all, it is largest of all, it is largest of all. Put values in that. Largest integer in terms of s, largest, that is x plus 5 over x plus 5. What is the value of x? Put here s minus 15 over 5 plus 5. Taking LCM, 5 is LCM, s minus 15, 5 5 the 25, minus 15 plus 25, minus 15 plus 25, I have s plus 10 over 5 is the largest integer in terms of s. Largest integers in terms of s, that is s plus 10 upon 5, s plus 10 upon 5. That is work of a beginner. X plus 1, x plus 2, x plus 3 consecutive integers. If you have a good grip at integers and you are satisfied with the fact that 1 is the difference between consecutive integers, then you can sucking this question, precise this question as x is the middle integer, x plus 1, and x is x plus 2. Prior to this x is x minus 1. Prior to this x minus 1 is x minus 2. Look at this, the difference of 1, x minus 2 plus 1, x minus 1, x minus 1 plus 1, x plus 1, x plus 1, x plus 1 plus 1, x plus 2. This is, what is the beauty in that case? Find their sum. Sum is s. If you sum them, minus 2, positive 2, negative 1, positive 1 cancel, you are going to have 5x is equal to s. So simply x is equal to s over 5, x is over 5. So this is our largest. Put in the largest one. Put in the largest. It is to be x plus 2. What is x? S over 5 plus 2. Take LCM. 5 is the LCM. S plus 2, 5 is 10. S plus 10 over 5 is the same average in that case. That is another way for obtaining, or supposing, assuming that these are the consecutive integers. These are the consecutive integers. There is beauty in such type of supposition, they are going to be cancelled. They are going to be cancelled. Whenever you find some x in a single step, you have x, put and work, it works wonders. Okay, moving towards next question that reads as a jar contains only red, white and blue marbles. A jar contains only red, white and blue marbles. Okay, the number of red marbles, there are only red, white and yellow marbles. Red, white, sorry, and blue. And blue marble. These are the three. These are the, let me utilize this one-legged glass. Yes, red, white and blue. The number of red marbles is number of red marbles. Let me write R for the red marbles is 4 upon 5 of the white ones. 4 upon 5 of the white one. That's condition number 1. A jar contains red, white and blue marbles. The number of red marbles is 4 upon 5 of the white. And the number of white ones is 3 upon 4 the number of the blue ones. That's our condition number 2. If there are 470 marbles in all, find the number of blue marbles. Find the number of blue marbles. How many marbles are there? Total marbles 470. 470. How many colors we have? Red, white and blue. Let me write R for red, W for white, B for blue. They add up to 470. Now we have to find blue marbles. We have to find blue marbles. Instead of convert this complete equation into blue marbles, convert this equation into blue marbles. I can easily switch over. Instead of white ones, I can write 3 over 4 B. R same plus 3 over B, that's B is equal to 470. 470. Now I have to convert red into blue one, red into blue one, red into blue one. If I take a glimpse of this one, if I put W value here, then I can express red marbles in terms of blue. If I write instead of W 3 upon 4 B, 3 upon 4 B, I am going to have something like, let me write here, put W is equal value of W here. So R in terms of blue is to be 4 upon 5. I am plugging in the value of W. Let me plug in the value of W here. It will become 3 over 4 blue. 4 cancelled out. Red marbles are 3 upon 5 of the blue. Red marbles are 3 upon 5 of the blue. So instead of this red marble, I can write 3 upon 5 blue marbles plus 3 upon 4 blue plus blue is equal to 470. Another headache for a student, there is fraction 4, 5, taking LCM and how to do this. 4, 5 the 20, 4, 5 the 20, just multiply 20, you are going to get rid of this fraction. 4, 5 the 20, 20 is the fraction. If you are going to multiply 20 throughout, you are going to get rid of this fraction very easily. Multiply by 20, multiply by 20. In order to get rid of fraction, it will become 20 times, let me write 20 times 3 over 5, 20 times 3 over 5 blue plus 20 times 3 over 4 blue plus 20 times blue is equal on that hand side 470 times 20, 470 times 20. If I apply table here 4 times, it will become 4 3 the 12b, 4 5 the 20, 4 5 the 20, 4 3 the 12, 4 5 the 20, 5 3 the 15b plus 20b. I am going to have 470 times 20. Add them, 12, 15, 27 plus 20. It will become 470. My magic figure, 470 times. I am deferring the calculation. I am deferring the calculation as long as it is possible. So divide by 47. Divide by 47. I have 10 times 20. So the number of blue marble is 10 times 20 is 200. So the number of blue marbles is 200. So the number of blue marbles is 200 in that case. 200 in that case. Really very easy. A jar contains red, white and blue marble. Three types of marbles. Where the number of connection between red is 4 over 5 times blue. 4/5 of white. Red is equal to 4/5 of white. And white is 3/4 of blue. And white is 3/4 of blue. They are in total 470 marbles, red plus white plus blue. I have, and we are asked to find a number of blue marbles. Try to convert this whole equation into blue marbles. Blue, let me remain blue for blue. Instead of W, I have written 3 over 4 blue. Blue. I have converted this red into blue. First, I have put W, white ones, that are equal to 3 over 3 times 3 over 4 time B, 3/4 of B, 3/4 of B. I have introduced the value of W here. W here. It is 4/5 of 3/4 of B, 4 cancel. R is equal to 3/5 of B, 3/5 of B, 3 over 5 of B. Instead of red, I have written 3 over 5 of B. I have inspected, there is a fraction, 4 times 5, it's 20, multiplying by 20 to get rid of fraction, and I have the number of blue marbles, that is 20. I am in frame? Good. Moving towards fourth question. Moving towards fourth question, it reads as a fundraiser, the Key Club was selling two types of candy. As a fundraiser, the Key Club was selling two types of candy, lollipops at 40 cents each and chocolate bar 75 cents each. And on Monday, the number on Monday, the members sold 150 candies and raised $74. How many lollipops did they sell? How many lollipops did they sell? Two types of candies are there. They are selling candy. Let me write L for lollipop, C for chocolate bar. C for chocolate bar. Lollipop for 40 cents. 40 cents. And chocolate bar for 75 cents. 75 cents. Total number of candies is 150. 150. And revenue generated on a specific day, Monday, it is $74. 74 $74. It's how many candies have been sold? 150. How many candies have been sold? 150. And there are two types of candies only, lollipop at 40 cent each, and the chocolate bar, I think, at 75 cents each. And the total revenue is 74. It works wonder. We have total figure 150. I can write as X and 150 minus X. X and 150 minus X. They are my chocolate bar, they are my lollipop. Chocolate for 75, X plus there is lollipop at 40 times 150 minus X. My total revenue is 74 here. 75 is cent, 40 is cent. Let me convert this dollars into cent by multiplying 100. I have parallel the unit cents. I have multiplied dollars with 100. Or either I have to divide 75 by 100 as well as 40 cents by 100 in order to convert 75 and 40 cents into dollars. On the other hand, I have converted dollars by multiplying 100 into cent. Look at this. Total number of candies is 150. I can easily split them in that. In single variable, I am going to solve this one. Otherwise, I have to take this is for L, this is for C, two unknown and two equations. It also works, but it's really very simple. 150 x, 150 minus x. If you add them up, minus x cancel, still you are going to get 150 the total. I have further suppose that this is my chocolate bar 75 cents and this is my lollipop for 40 cents. And I have calculated and I have converted $74 into cents. Okay, now calculate 75x. 415 the 60, 07. It will become 6000 minus 40x is equal to 7400. 7400. Now look at this, 75x positive minus 40x. It will become 35x. Let me shift 6000 on the left hand, on the right hand side. 7400 minus 6000. So I am going to have 35x is equal to how much? 1400. Or x is equal to 1400 divided by 35. 35. Apply a table of 7 5 times, here 2 times, means 200 divided by 5, or table of 5 4 times 40. So x is by 40. X is my 40. What is x? X is my chocolate bar. X 40. But we are asked to find lollipop. Lollipop. If I insert value of x is here, 150 minus 40. 150 minus 40, I am going to have 110. 110. So these are the number of lollipops. 110 lollipops have been sold. On the other hand, only 40 chocolate bars have been sold in that case. 40 chocolate bars have been sold in that case. We are asked to find number of lollipops. Lollipops. They are 110 in that case. 110 in that case. If you want another strategy, if you are going to solve separate for chocolate bar and lollipop, let me solve this for you in 2 dimensions. How many? They are total 150 candies. So I have lollipop plus chocolate bar. They are total 150. That is only figure. Lollipop, number of lollipops L, number of chocolate bar C. They are total 150. And the revenue wise, lollipop costs 40 cents and chocolate bar 75 cents. And revenue wise, we have raised only $74. $74. They are both cents. Multiply this with 100 in order to make unit parallel. So I am going to have L plus C is equal to 150, and this one is 40L plus 75C is equal to 7400. You can adopt this strategy to solve for lollipop. Multiply this one with 75 and you are going to solve this as 2-dimensional equation. But this strategy, total 150, how it will split this x and 150 minus x. Look, we have a single unknown, that is x. If we make same model here, that is 40x plus 75 times 150 minus x, that is total revenue 7400. We are going to have x is equal to, we have just calculated x is how much? X is 40 in that case. We have calculated x is 40. X is 40. So the number of, what is this? We are asked to find how this. You can easily find x. And what is x here? In that case, you are going to have what? You can solve it on your own. I have done in that fashion in the previous frame. That is 75x plus 40 times 150 minus x is equal to 7400. So in that case, I am going to have x is equal to, what is my x? Is 40. X is 40. So the number of chocolate bars are 40. If I put 40 here, 150 minus 40, I am going to have 110 is the magic figure for my lollipops. For my lollipop, that is 110. That is 110. Such type of model facilitate your calculation. Such type of model will facilitate your calculation rather than finding two unknowns, solving simultaneous equation. It works wonderfully within no time. Question number 5. Let me move to question number 5. That is, on a certain project, let me use my glasses. On a certain project, the only grades were awarded are 75 and 100. 75 and 100. Two grades are possible. 75, the other one is 100. If 85 of the students completed the project and the average of their grade was 85, 85 students completed the project and their average is also 85. 85. We are asked to find the number of students who earned 100. Who earned 100. Average is given by sum divided by total number. It's equal to our average, our mean. Normally, sum we have 75. How many students are there? 85. 85. 85. Same split situation. X and 85 minus X. X and 85 minus X. X and 85 minus X. So I am going to have 75 times X. How many students? Suppose X student who have secured 75% grade. X are the number of the students who have secured 75 grade, and while 85 minus X is the number of students who have secured 100 grade. That is 85 minus X. Total number of students, that is 85, and average also given to us, that is 85. Total number of students 85. How to split this? X and 85 minus, because we have only two grades, 75 and 100. 75 and 100. Suppose X is the number who secured, obtained 75, and 85 minus X is the number of the students who secured 100, and their average is given to us 85. Average is given by sum 75 times X plus 100 times 85 minus X. Number of students who secured 75, number of students who secured 100. Their total figure is 85 and their average is 85. Solve for X. It works wonderful for you because we have a single equation, a single unknown. It works wonderful. Otherwise, we have to make two equations and we have to solve simultaneous. Shift 85 here. It will become 75X plus 8500 minus 100X is equal to 85 times 85. I have 75X minus 100. It will become minus 2500X, 25X, only 25, 25X plus 8500. Multiply 85 into 85. If I am not wrong, 7225 is the magical figure for this. Shift 8500 on the right hand side. 25X is equal to 7225 minus 8500. I am going to have minus 1275. Solve for X, minus cancel. X is equal to 1275 divided by 25. We are apply table of 25. 525 the 125. 525 the 125. 2 carry, it will become 21. 25 the 25. So X is equal to 51. So X is mine 51. What is 51? 51 is the score. Students, there are 51 students who have secured 75 grade. There are 51 students who have secured 75 score, but we are asked to find how many earned have 100. Put 51 here. 85 minus 51. I am going to have some figure of 34. 85 minus 51. 4 and 3, 34. So there are 34 students who have secured 100 grade, and 51 is the number of students who have secured 75 score, and we are asked to find the number of students who secured 100. They are 34. Finally, we have arrived at our final question. Aaron has 3 times as much money as Josh. Aaron has, I beg your pardon for pronunciation if I am not pronouncing this proper noun incorrect. Aaron has 3 times as much money as Josh. A for Aaron, 3 times Josh. Aaron has 3 times as much money as Josh. Aaron has 3 times as much money as Josh. I have written here. It's my condition 1 according to question. Second, if Aaron gives $50, Josh will then have 3 times as much money as Aaron. If Aaron gives $50, He is giving away, A is giving away $50 to Josh. To Josh. Josh is receiving $50. Josh is receiving $50. First condition is Aaron has three times as much money as Josh. When Aaron gives $50 to Josh, Aaron is giving $50, Josh is receiving $50, then Josh is going to have three times the money as Aaron has. Then Josh is going to have three times as much money as Aaron has after giving away $50. After giving away $50, and Josh after getting $50. Josh is going to be three times of Aaron. So we are asked to find how much money do they have collectively. This is A is equal to 3, the first condition, that is 3 times A minus 50, J plus 50. Introduce instead of a 3J here, I can write 3 times instead of a 3J minus 50, A is equal to J plus 50. It will become 9, J 3 5 the 15, 0 same, J plus 50, solve for J, shift J here, 9J minus J, 50, shift 150 from the left right, it will turn to be positive. So 8J is going to be 200, or mine J is 200 over 8, 200 over 8. Applying table of 2 4 times, and there 100 divided by 4, it will become 25. It will become 25. So Josh has $25. Josh has $25. Josh has $25. Josh has $25. Put here, Aaron is going to have 3 times 25, it will become 75. 75. Josh 25, Aaron 75. If you add them, 25 plus 75, it will become 100. It will become 100. So 100 is the answer. One can easily verify whether we have attempted it, solved it right or wrong. One can easily arrive at the result. Look at this. Aaron has 75, Josh has 25. If Aaron and Josh, Aaron gives 50 to Josh, it will become 75 minus 50, 25 plus 50. It will become 25, it will become 75. Look at this. First, Aaron is 3 times Josh. First, Aaron is 3 times Josh. After giving away after giving away $50, Josh is going to have 3 times of Aaron. Josh is going to have $75, Aaron 25. That's my tiny effort for you guys to explain to you how to attempt word problems. It's all by itself. Next.